In this lesson, we're going to talk about sum of a geometric sequence, the second special case. Even though I call it a special case, the technique used is very general. Okay, so the question goes like the following. Evaluate 2 plus 6 plus 18 plus 64 plus all the way to 2 times 3 to the power 10. So first of all, you recognize the pattern of this sequence here, the terms of the sequence, 2, 6, 18, 64, 2 to the power 3 to the power 10, is basically the next term equals the current term multiplied by 3. And that we have seen it in the first part of this lecture. So 6 equals 2 times 3, 18 equals 6 times 3, 54 equals 18 times 3, and so on. And the general term in such a sequence can be written as 2 times 3 to the power k minus 1, if the k is the index of the term. So 2 times 3 to the power 10 is actually the 11th term. This is the 11th term. Okay, and such a sequence would define it as a geometric sequence. The question now is to calculate the sum of this sequence. In the first part of this lecture, we did a sum of another special case is 1 plus 2 plus 4 plus 8 plus all the way to the power 10. And in there, we illustrated using two approaches. One is brute force, but brute force by using observation. And you see the pattern of the sum actually has a relationship with the next term in the sequence. The other method is more general, and we're using the same method here. The method there is taking the sum and using a symbol S to represent the sum, and then we multiply 2, basically transfer the current term to the next term, because next term equals the current term times 2, right? By doing that transformation and then taking a difference, we get a sum. It's very easy to write. So here we're going to be using the same approach. And we're going to write S equals 2 plus 6 plus 18 plus 54 plus all the way to 2 times 3 to the power 10. And remember, the ratio between the current term and the next term, or actually rather the next term over the current term, is a 3, right? So what we want to multiply this S, remember that we want to transform the current term to the next term. So clearly we want to multiply by 3 to get the next term. And the technique is multiply 3, both sides of this, the first equation. Let me write down the first equation 1. So the second equation is basically taking the first equation multiplied by 3. That gives you the left side 3 times S. The right side is each term you're going to multiply by 3. 2 times 3 plus 6 times 3 plus 18 times 3 plus 54 times 3 plus all the way. And to illustrate, I want to add the second last term, 2 times 3 to the power 10 plus. So the second last term becomes 2 times 3 to the power 9 times 3. The last term equals 2 times 3 to the power 10 times 3. Okay, in here you recognize 2 times 3 is really the next term, 6. Plus 6 times 3 goes to the next term, 18. Plus 54. Plus 162. Plus the second last term is 2 times 3 to the power 10. And here, the last term becomes 3 to the power 11, 2 times 3 to the power 11. So the technique we illustrate before is basically we want to using the second equation minus the first equation. So the left side minus, that's equal to 2s. Remember, 3s minus s is 2s. And the right side, interesting happens. Look at the term for the second equation on the right side. This is almost the same as the right side of the first equation. They have a lot of overlaps. And that's exactly by our design. We multiply 3, we transfer the current term to the next term. So if I write down the right side of the second equation, minus the right side of the first equation, you see there's a lot of common terms. 6 cancels 6, 18 will cancel 18 there, all the way to 2 times 3 to the power 10 will cancel with the 3 to the power 10. Sorry, the last term there in the first equation is 2 times 3 to the power 10. Except only this term and this term does not exist. So 2 times 3 to the power 11 does not exist in the right side of the first equation, and 2 in the first equation does not appear in the second equation. So this whole thing equals 2 times 3 to the power 11 minus 2. So what is s? The s is going to be both sides divided by 2. So s is going to be equal 2 times 3 to the power 11 minus 2 divided by 2. That's equal to 3 to the power 11 minus 1. And that's the answer for this sum. It turns out to be very, very easy. And even though this is a special case, the technique used can be generalized into any geometric sequence. And that's the end of this lecture.